All right, so we are on day number 5 of OSPF process. Okay, so we have come through a lot of topics in the OSPF protocol. Basically, we have done theoretical topic and parallelly we have also done lab to prove those theoretical topics. Okay, so today would be the last day of OSPF. So before I jump into any further topic, I will take a quick revision. So let me understand how much you guys have followed and where do you guys stand. Okay, very silly questions. I'm not going to ask any complicated or any scenario based, just a silly questions. Okay, so tell me what is the multicast IP address of OSPF? What is the multicast IP address? You can make use of the chat window to type. Okay, great. Okay, great. Okay, great. Second question, tell me what is that LSA number that we see between two different areas. Let's say I have area 0 and area 1. Now what is that LSA that will take all these routes to area 0 and vice versa? Okay, now I understand some guys have not understood this part. Okay, so the right answer is LSA 3. Okay, those who have answered LSA 4, so to you guys LSA 4 is seen when you have external routing. Okay, external routing like EIGRP or BGP or any other things, then comes your LSA 4 and LSA 5. Now I only said there were only two OSPF areas, so these routes to advertise on area 0 and vice versa, it would be LSA 3. LSA 1 and LSA 2 are limited to the areas. So this area will have 1 and 2 and this will have 1 and 2, its own 1 and 2. They don't get distributed, they don't get transferred to other areas, they remain within the same area. It's your LSA 3 which will communicate inter areas in the sense between the areas. LSA 4 and LSA 5 is when you have an external routing. Okay, fine. Now uh, tell me the OSPF states. You can just name those, or you can just tell me that there are so many states, and you can just name them. Okay, OSPF states. So do you know? Do you remember how many states we discussed? Okay, and what are they? I mean, so anyone? Okay, so I have multiple answers. So let me just write it down. It's down, init, two-way, extract, exchange, loading, and full. So how many are they? 1, 2, 3, 4, 5, 6, 7. Okay, so the right answer is 7 states. So this is the order: down, init, two-way, extract, exchange, loading, full. Fine. Okay, now a simple scenario based question. So let's say one of your interviewer asks you that there is a problem with the neighborship formation. Okay, so tell me the factors which could impact this neighborship. So let's say these are brand new switch routers, and we have just uh, powered up the OSPF process, and the neighborship is not coming up. So how would you troubleshoot, or what are those components which due to the mismatch can bring down the neighborship? Okay, I agree. Hello and hello timer mismatch is one such factor. So let's say hello timers are same, or by default hello timers are uh, let's say it's 10 and 40 seconds and 10 and 40 seconds. What else? What else? No, MTU size is not for neighborship. Authentication, yes. Hello timer, yes. Authentication, MTU is not again not coming under neighborship. Okay, that I agree. Interface should be up. I take it as a default that interface are up. But apart from hello, what else are required components for OSPF to become neighbors? So you guys answered hello and authentication. Now there are a couple of many things. Yeah, hello and dead timer, I write it as one single components. So I've written two of them. Okay. No, process ID in the case of OSPF don't have to be same. Process ID is locally significant. Very important and very tricky question. This is something which every interviewer asks the candidates. If I have process ID 1 and I have process ID 100, will it create impact on neighborship? No, it doesn't in case of OSPF. Okay, they are locally significant, but in case of EIGRP, yes, they will be significant because we configure autonomous system in case of EIGRP. Okay. Attempt we don't use because attempt is used in multi-access non-broadcast environment. So by default, when we have the broadcast, we don't see attempt. So that is why we don't discuss attempt in lot of scenarios. These are, if you remember those network types, the first one was broadcast, point to point, point to multi-point broadcast, point to multi-point non-broadcast, and then non-broadcast. So attempt is one such in those backward areas which are obsolete nowadays. Okay, so we don't discuss this. So it's 7 states. Okay, if your interviewer asks a side question that it's a multi non-broadcast, then yes, you can include attempt, which should make it 8. Okay, so most of the time it's 7 only. Router ID, no. Router ID is just a prerequisite factor to bring up the process, but they are not a uh, they don't have to be matched, or they cannot match or something. They are not a neighborship criteria. This is just to bring up the OSPF process. Okay. Anyway, so okay, I see couple of answers. Might be I have to bring up the chat here. Area ID and area type. Okay, good. So I have area ID, I have area type. That's great. Now what is the last one here? The important one. Yeah, area is nothing but area ID. So I have mentioned here. Area types are all your stub, non-source stub. Okay. Now what is the last one? Very important and very basic one. So let's say I have 192.168. Yes, great. It's subnet mask. Okay. So let's say I have 192.168 1.1/32, and on other side I have 192.168 1.2/24. Now the subnet masks are different. Now they will not form neighborship. So remember, these are the factors for two routers to become neighbors. Router ID is a prerequisite. Okay, I cannot consider this to be one of them. It's a prerequisite. If you have router ID, then only the hello packet will be sent across, and once they are sent across, then they get checked thoroughly if they have a matching parameters. Okay, great. So till here you guys are good. Okay, now let's say in the case of stub, what happens technically. Okay, I don't want to know what is stub, how it works, all those things. Technically, what happens inside stub? Let's say I have a area and I just enable stub. Now what does it do? What is stub going to do? In the backend, what happens as soon as you bring stub on this area? So you know that external routings will be disabled immediately, right? But how is this external routing getting disabled? What in the backend will? Okay, I agree. I said that's fine. Okay, I said that's fine. No external routes. Yes, that's great. But in the backend, what is happening so that these get suppressed? These are theoretical concepts that a static route will be injected. Okay, great. So you are basically suppressing all LSA 5. Okay, so remember that you're suppressing all LSA 5 by enabling stub, and these are right answers. I don't say they are wrong. And how is then it's going to work is by injecting a default route. Okay, great, fine. Now let's say in the case of non so stubby area, if a interviewer asks you that the e bit, okay, let's say the n bit is 1 and e bit is 0, what does this say? What does this mean? I'm asking this because I have showed you over on Wireshark in the last class. So I just want to make sure how much have you captured from the previous classes. So in the non so stubby area, I have n equals to 1 and e equals to 0. So what does basically it's significant? Okay, great. That's great answer. So when you have n equals to 1 and e is nothing but external routing. Okay, so that means you have NSA powered on. Okay, so what else do we have? It can import autonomous external route and send. Yes, that's right. Okay, so basically what happens is all your LSA 5 routes will be converted to 7 wherever you have the NSA activated, and then your ABRs will retranslate from 7 to 5, and that's how the other areas like 0 and let's say you have area 40, they are going to get aware of the external routes because they have the LSA 5 flowing across. Okay, only this area you're suppressing 5, but at the same time you don't want to limit the external routes because you need the external routes on the other areas. Okay, so that's where NSA is seen. Okay, great. So that was a good answers from a lot of you guys. So let me see if I can take few more questions before I start. Okay, one more question. So tell me, in the case of auto cost reference and in the legacy cost formulae, so let's say both have the formulae reference bandwidth equals to reference bandwidth. Okay, as you all know, bandwidth is nothing but the physical interface bandwidth. Now what is the reference bandwidth in case of auto cost and what is the reference bandwidth in the case of legacy cost? So anyone remember what is the number that we had taken up as a reference? So okay, first answer for legacy. Okay, great. So in the case of legacy, we took it as 10 to the power 8, which is nothing but 100 Mbps. Okay, that's the reason all your links after fast Ethernet like FA, GI, and all other 10 giga 8, they had by default the OSPF cost value of sorry 1. Okay, to avoid such drawbacks, we started taking up the reference of this 10 to the power 10 in the case of auto cost. Okay, so when you enable auto cost, make sure all the routers have this upgraded reference cost. Okay, otherwise one router will still work on a uh, legacy cost formula and the others will work on the upgraded formula. Okay, so the rest I just assume you guys know about it, like how is router ID created, all those things. Okay, one question which I just recalled. So let's say this is area 0. It's a point to point area type. Okay, so when I open up the database, OSPF database, I see that LSA 1 is present, but there is no LSA 2. So how would you troubleshoot this scenario? So you got my question, right? Okay. How about others? How would you guys troubleshoot? Okay, fine. Both are right answers. Okay. In case of point to point, there is no DR BDR election, and when there is no DR BDR election, there will be no LSA2 getting generated. Okay, LSA2 is generated by your DR router, and if there is no DR router, there is no LSA seen in such scenarios. Okay, so we covered till here. Great. Okay, so thanks everyone for participating. Now let me take down some new topics. So I was discussing about summarization in the previous class. Okay, and I was stuck showing you one of example. So in today's class, I will show you some examples. Okay, I have written down the configurations over here so that you guys can parallelly see what configuration I'm doing. Okay, so let me go to the topology. So what is what kind of summarization I'm doing and what is this summarization? Okay, so let's assume this router has couple of networks. Okay, 192.168.24.0/24, 192.168.25.0/24, 192.168.26.24. Okay, so these network will get synchronized in all of the database. Okay, database of all of the routers. The same database will also flow across on inter areas. So that's a speciality of a link state vector. The OSPF is considered to be link state vector because they will know about each and every networks. Now let's say the routing tables, the routing entries of each one of them will now unnecessarily getting piled up. Okay, so you will see like 100 of routes inside your routing table. Now while troubleshooting, You will feel lot of difficulty searching for the right network to troubleshoot, and the rib configuration or the rib check will be happening slower. Okay, so what is the best preferred way is to minimize this routing entry. So what I am going to do is, instead of advertising three networks or three different networks, I'll just advertise it on a broader network. So what happens, this router will now no longer have three separate network. It's going to have one single network. So that way we are trying to minimize our routing information base. So I'll go to the router 2. Okay, so over here, and what will I do? I'll first create some loopbacks. So let's see if I have them. Show IP int brief exclude unassigned. So I have created 3 additional loopbacks. So once I create them, I have to advertise them inside the OSPF process. So what kind of process ID I'm running here? It's 100. Okay, so under OSPF 100, I have advertised these additional routes or these additional loopbacks network. As soon as I do this, okay, as soon as I go and do this, so let's see from my Mumbai 6. Where is Mumbai 6? It's here. Where have I added those 3 additional network? It's over here. So you will see all these networks will get advertised and you will see them inside routing base. Okay, so if I do show IP route, so you will see individual network like 24, 25 and 26. Now they are just getting piled up. Okay, so what I am going to do is I am going to make use of summarization. Which router is going to help me? It's the ABR router. In case of OSPF, it's your ABR routers where you need to configure the summarizations. Okay, so summarization is done on ABRs. Fine. Now which is ABR? In my case, this is acting as ABR router. Okay, the router number 4. So what I go and do is I add one single line of command. Now that's this command. Okay, so let's add it over here. So I'll go to router OSPF 1. I'll say area 0 range is that word which is used for summarization. So what is that network that you want to summarize? It's 192.168.0.0 and you are going to make use of /16. Okay, and what is the cost you are going to assign? So let's calculate the cost. Okay, so once you summarize, you basically have to define the cost value. So cost would be, so what is the cost across this? It would be 10. And what would be the cost of that single loopback? 1. So totally I can give it as 11. Okay, so over here, while configuring the cost, what is the cost for this? It's 10 plus 1. So I'll give it as 11. Okay, great. So I have enabled summarization, just a single line. Now let me go to this router, the router which is in other area, and let's see the routing table. Now if you see, the routing table has been summarized. Okay, what were the result earlier before summarization? It was kind of this. You had 3 different networks. Okay, so basically you had 23, 24, 25, 26. Now they are all summarized within single broader network. Okay, you can still ping them. Let's say 192.168.26.1. So you can still reach them. So just summarizing doesn't mean that you are losing the reachability. Your functionality will still be present. It's just your routing entries that you're reducing on your routing information base. Okay, so this is about summarization, which was left out in the last class. Okay, so we just checked that. Okay, so what is the next topic? The next topic is route filtering. Now, why do we use route filtering? So let's say if I take you over here. So let's say I was advertising multiple networks like 192.168.24.0, 192.168.25.0, 192.168.26.0. Okay, so we just saw the summarization behavior. Now let's come out of summarization. Okay, let's come out of summarization. So let's say by default all these networks are getting advertised 192, 168, 24, 25 and 26. Now let's say I want to restrict one of the network so that it doesn't enter inside this area. Okay, so let's say my customers say that I want to restrict entry of one of the network. This network can go elsewhere, I don't mind, they can go anywhere else, but this network don't have to enter inside area 40. Now these kind of topics or these kind of concept in OSPF is called as filtering. Okay, so we have three methods of doing filtering. One is called area summarization. With the help of area summarization, I can easily achieve that. Now let's say if it is beyond the area summarization capabilities. Now the second method would be called as inter area, okay, inter area filtering. So we can achieve that with the help of inter area. And the third one would be, now there would be some time the filtering is done on router specific. Okay, I cannot do it on ABRs or I cannot do it on anywhere else. Let's say I want to restrict one of the network. Now I need to do it router specific. So for such thing, we have something called as local filtering. Okay, three ways of doing filtering. I'll show all the three to you guys. So first one is area summarization. So let me take you back to the PDF. So what is route filtering? It's a method to select the routes. So you can basically select the route which you need to permit, and you can also filter out the one which you don't need it. So the first one here is summarization method. Okay, with the help of summarization, it's very easy. So let's say I had three networks here. I had the 24.0 network, 25 dot network, 26 dot network, and I want to limit all the three. I don't want them reaching to area 40. Now this I can achieve with the help of summarization, the summarization filtering. It's called as summarization filtering. Okay, so I'll go back over here. So what is that command that I am using here? Let me show you that. Okay, so I'll take out all these unwanted things. Okay, so this is my command that I configured for summarization. Now summarization filtering is done by adding one additional keyword called as not advertise. Okay, so I have highlighted in a green color. So what I do is I'll go and copy this, and then I'll add not advertise. Okay, I'll remove the cost values. Okay, over here I say not advertise. So once I do this configuration not advertise, let's go to the Mumbai 6 router, which is over here. Okay, and let's see the routes. So let's see what happens to these routes. So you will see there is no 192 series routes now. So basically you are filtering all of the routes with the help of summarization command. Okay, so let me take this out so that I can show you the next way of filtering. So in the case of first way, that is summarization filtering, with the help of the command, just add one additional command which would filter the complete networks. Okay, so you don't see anything in 192, you can just in filter it out, or you can grep it out. Okay, so as soon as you removed it, it has come back. Okay, so it has come back now because you have removed the summarization filtering. Okay, now the second type is called as area filtering. Now why do you think area filtering is required? Because summarization was still the simpler option, right? So area filtering, or the second type, is used when your first method is not effective. Now let's say I have three networks. Okay, three networks. So by default my customer say I do not need this network entering over here, but he still need 2.0 and 3.0. Now you cannot make use of area summarization, because area summarization would suppress all the three. That's what we just checked it now, right? So all your 23.0, 24.0, 25.0, 26.0, all of them were not advertised, right? Now that's a drawback in case, or that's a limitation of your first type. So the second type is when you want to suppress one of the network, but still you want to allow the rest of three. So that's when you call it as area filtering. Okay, so in this case, in my case, let's say I have 23, I have 24.0, I have 25.0 and 26.0. So let's say I want to filter out one of the route, but still I want to allow the remaining three. Okay, I'll see the route over here. After I configure, I will go and check the routes. Okay, so let's do the pre-check now. Let's see, I have all of them. So this is my sixth router. So let me grep it for 192.168. So I see all of them, 23, 24, 25, 26. Okay, so what is the command to get it up or get this kind of configuration? So we will make use of the prefix filter. Okay, so I'll go to the Mumbai router 4, which is my ABR. Okay, I'll apply the prefix list over here. So let's do the configuration. I'll show you how it works. So initially I have to define a prefix list word. Okay, so it's asking me for a word. So let's say I'm going to make use of prefix filter. This is acting as my word, and then it's asking me for some sequence number. So let's say first sequence will be defining the deny statement, and the next sequence would be allowing everything. So I say I'm having sequence number of 5, and over on 5 I want to deny one of the network. So let's say in my case it's 24, and this is a loop back address. Okay, and it's also supporting the CIDR value, so I can straight away go and give 32. Why do I use 32? Because this was a loopback address, and in case of OSPF consider this to be host, so it's slash 32. Okay, so this is my first statement where I am denying this, and in the next statement, that sequence number 10, I'm going to permit all of them. Okay, so all of them. So let's say I want to allow 192.168.0.0/16. Now I'll go inside router OSPF process, and I'll apply this prefix filter. Okay, that is when this get applied. Just defining will not bring up them to be functional. So whatever you have defined, so you need to apply this inside OSPF process. Okay, so I go over here, I say these are the routes, or 192.168.24 dot network is entering towards 40, what is the filter list I'm making use of? What is that word? It's called as prefix filter. Okay, so there is one word here that's called as prefix. Okay, and on which direction are you going to apply? So that's something which we need to understand. So what I'm trying to do is, my 24.0 network, which is entering over here, which is in phasing, okay, and it's going towards area 40. So I say my area 40 prefix length so and so in the inside direction, because this is going in this direction, which is in. Okay, so I take it as in. So I come over here and I say it's in phasing. So the moment I have configured this, I'll go to my Mumbai 6 router to verify if the routes have been filtered or not. So let's say I am going to grab this. Okay, so looks like it has taken down everything, but I don't want all of them. Okay, I still need the other. So let's see what is not working here. So let me check it out for prefix filter. So I have this denied, that's fine, and I have this permitted. Okay, the rest ones are permitted. What about my OSPF process? Area 40 prefix. Okay, I hope this is a right word. Prefix filter in phasing. Okay, so that's great. So let me see why is it not coming up. So I just removed it off to verify if 192 comes up or not. Okay, it has come up. Okay, so we see 192. Now, there is some problem with the syntax. So let me verify. So this is deny and this is permit. So that's great. I go to router OSPF1. I say area 40 filter list prefix in the inside direction. Okay, strange. It's taking all of them. I just want to take one of them. Okay, let me try by one more thing, that is by making use of out, okay, instead of in. One 192, 168, you have all of them. Okay, so this is not effective. Okay, this command is not effective. So I just need to tune this. So let me apply this on area 0. Okay, I have applied this prefix list on area 0. Okay, So I'm giving one more possibility, that is area 0 prefix filter out. Okay, so that's losing the entire thing. Okay, so let me see why exactly that's happening. That could be because of the route that is being defined. So you have 24.1 sequence deny, and you have 192.168.0.016. Okay, so this should have worked. I'm not sure why it's not taking up. I don't need this line actually. Okay, let me see the chat window for a second. No, deny comes first. So the deny comes first and permit comes later on. The reason is they are checked sequentially. If you have permit on the first line, that means it's permitting even 24. It will not go to the next line. So first it gets denied, then it goes to the next line. Okay. So let me check why it's not working, because I have tested this in the lab. They are a working condition. Okay, so I have 24 here. Great. And over here I say area 40 filter list prefix filter inside direction. Okay, so we are losing the entire networks. Okay, that's something which I don't want. That is why I'm making use of prefix length. If I had to lose everything, I could have made use of area summarization. Let me check if there is any other things that's coming over here. 16 sequence 10. Okay, let me do one more thing. I'll make use of some other word. Okay, so let's say IP prefix. Let's give OSPF ACLs. Let's give a sequence number of 10. Let's deny the first network 192.168.24. So let's give it as 24.0. And then in the sequence number 20, I'll permit the rest of the networks. Okay, I'll go to router OSPF1. I'll say area 40 filter list. This is the filter list. And on which direction? It's filter network sent to this area. So it's basically in phasing. And I'll remove the previous line. Okay, I have already removed. So let's give it a try. Okay, so that's not working. Okay, let me make it as 1, because that's a single network. /32. Okay, so this prefix length is not behaving as per expectation. 24.1, 24.0. Okay, so let me give it as 24.0. Okay, one last trial before I move on. Okay, I think this will take up. Okay, so let's give it a try. Okay, I have to bring the filter here. Okay, let me try this for the last time. Okay, it's taking down everything. Okay, so I'll tell you this in the next class. Might be there's some silly mistake, or might be there is some configuration which is overlapping, and because these are the tested in the lab already, so they are a working commands. But anyway, I'll tell you this in the next class. Okay, so the third type is here called as local OSPF filtering. Okay, so this is a scenario when the first two are not effective. Let's say the summarization is not effective, neither the area filtering is not applicable. Now, in that case, local OSPF filtering is when you go straight to that box, to that router, and you just filter out. Okay, so in some scenarios, routes need to be removed from the specific router. Since OSPF behaves in a link state protocol, it's going to maintain all of the area. But with the help of this, you can still prevent it getting installed in the routing base. Okay, so what happens is you will see the network 192.168.24.0 in your rib, but they will be not functional. Okay, you're still restricting the communication. So I'll show you how this works. Okay, so let me take out the second approach by doing or by adding a no command. So you will see all the routes. If I ping to 24.1, they are reachable. Okay, with the help of third option, they will still be present in the routing table, but they will be not functional, or they will not be pingable. Okay, that's called a local OSPF filtering. So what I do is I'll go to router 4, and now I'll make use of access list. Okay, in the second step it was prefix list, now it's access list. I'll go and define some access list. So let's say IP access list standard. Let's give some name to this. Let's say it's ACL OSPF 123, and let's define this. First I'm going to define my deny statement. And what am I blocking? I'm going to block 192.168.24.0, and now this is asking for wildcard mask. Okay, so this is a /24 network. Now let's permit the rest of things. Okay, so I can say permit all others. I'll go to the router OSPF process. I'll make use of distribute command. distribute list command. And what is the ACL I'm using? I'm making use of named ACL. Okay, so in this case I'm making use of, so what is the name that I have given? This is the name. Okay, so I say distribute, and on which direction? It's in phasing. Okay, now let me go to Mumbai 6 and let me try to ping. So now you see the ping is not reachable. Earlier it was reachable. You can see the ping was reachable to 24.1, but it's not at present because you have applied access list filtering, which is called as local OSPF filtering. Let's see from the routing information database. You will have the routes. Okay, you will have the routes, but they will be not reachable. See, they are dead. That's what it's called as. OSPF is a link state protocol. So routers are going to know about all the routes. They have to maintain identical link state database. But you can still prevent reachability, or you can still prevent them getting advertised, okay, with the help of distribute. So the three steps here are: one, you can filter it out with the help of summarization. The second one was area filtering. You have to make use of the prefix filter or prefix list. And then the third approach here is local OSPF filtering, which is called as which is with the help of access list and distribute list. Okay, route will be present but no reachability. Okay, so that was regards to filtering in the case of OSPF. Okay, the next topic here is default route originate. So let me tell you one scenario. Let's say this is a scenario. Okay, so what happens is, by default your ISP providers are gonna send you lot of prefix lengths. Okay, they're going to advertise multiple prefix networks or multiple networks inside the OSPF region. So in simple word, let's say I have two BGP routers, BGP router 1, BGP router 2, which are connected to ISP, and these BGP router are then internally connected with OSPF routers. You have OSPF routers. Okay, now what happens is, your ISP is going to advertise lot of networks to the BGP routers, and then the BGP router will advertise them towards OSPF domain. Okay, so you will see lot of routes being learned from BGP. Now I do not need this. Okay, I do not need lot of networks, so I can make use of some technology. In case of OSPF, it's called as default route originate to reach ISP. Okay, let's say I have user, he still wants to reach ISP. So what I can do is, on these links I can install some default route. Now that will be nothing but something like this. Okay, a default route will be injected which will point to ISP. I don't need multiple networks coming in from ISP. So what is the definition as per official textbook? What is the definition for default route originate, or why do we need this? Okay, so the common situation is where you have some internet facing routers running BGP with some ISP, probably receiving full routes, and you want to send a default route to the internal routers. Okay, so they will use the nearest router to send traffic distant outside the AS. So basically what happens is, by default these BGP routers, they will receive lot of networks from ISP, and then they will inject it towards OSPF domain. Now that's a drawback, because if you have lot of network, your routing database or routing table will have multiple entries. So to minimize them, you can just inject a default route pointing towards ISP. So that is the whole approach of this topic. Okay. So how do we do this? So there are two ways. One is called as default information originate, and the other one is called as default information originate always. Okay. So I'll try to show you both of them. Okay. So I don't have any configuration on this router as of now. So as I told you in the previous class, I don't save the configurations, okay, other than the initial basic configuration. So if you see my configuration now, they will be blank. So where do I keep those configuration? In my notepad plus plus. Okay. So let's see the configuration for Tokyo 7. Okay, here it goes. So Tokyo 7 is running on EIGRP. Fine. And on Mumbai router 6, which is acting as ASBR, will have the redistribution commands. Okay. So this router will have redistribution commands. Okay. So here it goes. So these are the redistribution command while injecting OSPF inside EIGRP and vice versa. I'll go over to the configuration mode. I'll paste it. So let me see if I get the external routes. Show IP route. So I do have the external routes. Okay, 113 and 114. So this is on external routes on OSPF. Okay. So with the help of default gateway, my target is to put them into default node or a default routing lines, okay, instead of multiple things. So let's see this. Okay, so I'll go to the Tokyo box. So let's see from the Mumbai side. So if I do see show IP OSPF database, so I have type 5 routes. Okay, I have the two external routes. So let's configure default gateway or the default routes. Okay, so I go to router OSPF 1. I say default information originate. Okay, I'm going with only one first command. I'll show you the next one. Okay, now let's see what happens to my database. So nothing has happened. Okay, now I'll go with the second line, that is called as always. So if you see now, you have an default gateway. Okay, so you can see there is a default gateway now. Okay, let's see on the Mumbai 2 router. So you can see there is a default route now which is pointing towards external routing protocol. So I can take down these two networks. I don't have to advertise this. So let me see what I have over here. So let me go to this interface and shut it down. So as you shut it down, okay, so let's see what protocols I'm running as of now. Okay, I have EGP, EIGRP, and on router number 6, okay, so I'll bring down this, okay, because this is leading to some confusion. Just don't get confused. 113 is not this at this moment, okay, that is this interface. So just to avoid confusion, I'll put that interface in the down state. Okay, so I'll go to interface E10/0 and put it shut. So as soon as I do that, okay, so now what happens, you do not have 113, you do not have 114, you will have an external default gateway injected. Now this will take care to reach to the ISP end. Okay, so you are trying to minimize the entries. So what did I do here? So let me go and explain you over on the diagram. So I considered this portion to be ISP. ISP was injecting lot of networks. It was injecting 113, it was injecting 114. So what I did, I went to this router, Mumbai router 6, and I made use of default information always. So by doing this command, I'll add a static route which is pointing towards this. I do not need the individual routes. I don't need to know where is 113, where is 114. Okay, so I'm just suppressing those multiple individual route by adding up one of the default routes. So as you know now that there are two commands here. So the one is with always, okay, and the other one is just, okay, so this has to be enabled inside process. Okay, so default information originate, do show run session OSPF. So you just remove that. So now if you see, you will lose your default gateway pointing towards ISP. Okay, so if you just add this line of command, default information originate, let's see, do we get this static route? So we don't get the static route. Okay, that's a default behavior. Don't worry that we are doing some mistake. So adding only this line will not bring up the static route. To get the static route, you must add always. So as soon as you add this, so you will see there is an additional route, okay, pointing towards ISP. And from the LSA point of view, do show IP OSPF database, you will see a static route, or you will see a default gateway. Okay, so let me once again remove this. Okay, so if you do as of now, so this will be replaced. Okay, this will be replaced by multiple individual ISP links. So as soon as I bring this command, that is default information originate always, it will bring up one of the static route or a default gateway facing towards ISP. Now regarding the two commands, okay, so when do you use the first one and when do you use the second one? So the first one will not bring up the default gateway if you do not have it in your routing table. Okay, so that means the first command, that is without always. Okay, so let's say the first command, it's functional when, okay, so if you use this command, so basically what it does is, to this command to be functional, you must have a static route already. Okay, you must have static route already inside your rib. But in our case, we didn't have any static route, but I still enabled it with the help of always. So this always keyword is used when you do not have in the routing table, but still you want to bring up the new additional default gateway. Okay, so there are two things, one is originate and always. So we use always when there is no default gateway in the routing information base and I want to bring it up. Okay, in case if I already have a advertised network, then I can just make use of originate. I don't have to add this keyword. Okay, and why is this used? It's used for your OSPF, which is pointing towards the ISP. Instead of having multiple networks, I'm just writing a static route or a default route facing towards the core service provider. Okay, so that's regards to default route originate. Okay, so that ends your topic, but before doing that, I have one small topic might be which is not in your portion. Okay, so let me show you the syllabus copy. Okay, so regards to OSPF, these are your OSPF topic. Okay, so multiple area summarization, filtering, the network types, and from the NRC. So you have, we will cover IPv6 later on. So we have covered IPv4, we have covered the neighborship relation and authentication, the network types discussed, the area types discussed, all the different routers like internal router, backbone, ABR, ASBR discussed. Okay, so there was no LSA type, right? I think we took it additionally. So was there any LSA to be discussed? Okay, so looks like LSA is your CCI lab. Okay, so you don't have LSA most probably, but we have done it. Okay, in our class we have done it. Okay, so one last topic here is virtual link. Now let me tell you what is virtual link. Okay, one easy question. So let's say I have area 0 here, I have area 40, and I have area 100. Okay, now I have these two OSPF areas connected next to next. Will they communicate each other or will they not communicate to each other? What do you think? So basically when I had all this network, they were getting advertised here and these networks were getting advertised on this with the help of LSA 3. Agree? Now I am asking you this question, between area 40 and area 100. Will they communicate to each other? These two areas will communicate to each other, area 100 and area 40. I'm not just ignore all other things. Okay, just ignore other things. You just think about these two areas which is kept next to next. No, not that way. You still have ABR. Okay, just think this is a ABR. Okay, which I can just keep it here. So let me do that. Okay, so let's say I have ABR over here. So what I need to do is I just need to do few networks here, and other few networks will be advertised in this area. So that's not a deal here. Okay, still there is ABR, but will they communicate? That's my question. I mean, will they advertise to each other? Okay, I understand we need virtual link, but technically why is it not communicating? No, I agree we need a virtual link, all those things. Okay, the theoretical topics I agree, but in the back end, why are they not agreeing? I'm not asking the solution for this. I'm asking why will they not communicate? Why do you need virtual link? Why by different area? That doesn't matter, right? You have area 0 and area 40, different areas. But why so special regards to this type? Okay, it's correct answer, but my question is back to back to the same thing. Why backbone area? Okay, this is right. This is right that the area should be connected to area 0. Okay, so this is also right. They are not directly connected, so you will go with virtual links. But technically, what is happening? Why are these two not communicating technically? So you guys are right that they are not directly connected to area 0. Area 0 is a mandatory area. But technically, why they are not communicating? That's my question. Why area 100 and area 40 are not communicating? They're connected next to next. They have ABRs. Now, what is the big deal? Why are they not communicating? Okay, not an issue. I'll do the configuration and then I'll show you. Okay, so what is technically not allowing you to communicate between two areas? Yeah, this is right, but I'm asking in the back end why what is happening? Okay, so let me tell you, back end your LSA 3 is not getting generated. Your LSA 3 are getting generated by your area 0 ABRs only. Okay, so your area 0 ABRs have a capabilities to generate LSA 3, and this LSA 3 is sending and receiving the advertisement. In this case, this is though ABR, it's not a ABR which is dealing with area 0 at either of the side. So there is no LSA 3 generation. If there is no LSA 3 generation, there is no way that this networks will be sent here, neither vice versa. The routes will be here. So what you do is you are going to create a virtual link. As soon as you create a virtual link with ABR which is connecting with area 0, your LSA over here will be getting generated, and that's how the areas will now get communicated. And that's why we say that if you have two areas, they will work functionally. Okay, the OSPF here will work functionally, the OSPF here will work functionally, but they will not communicate to each other. They need to be connected with the area 0 which is acting as a backbone, and in the back end, that's because of your LSA 3. What is LSA 3? It is the inter area summarization advertisement, right? So if there is no LSA 3, that means two areas cannot communicate. If there is LSA 3, then only the two areas will get communicate. Okay, so that's a little backend about that. So let's do the lab and let's see them technically. So I just power on this. Okay, I'll just keep it here, or let me keep it here if it's creating a little confusion. Okay, fine. So let me configure this. Mumbai router 13. Show IP in brief, exclude unassigned. I do not have anything. So let's say interface E0/3. The IP address here is 23.23.23.1.255.255.255.0. No shutdown. OSPF process, I'll just I can advertise the whole thing, or I can just advertise a single thing. So let me just do this. It's a wildcard mask. And on which area are they lying? So they are lying on area 40, right? So this interface is here, shared with area 40. So I'll say that it's area 40 network. Okay. Now I need to have one more loop back, okay, so that I can show you the example. So what I do is I'll configure one loop back. So let's say loop back 10, and this loop back will be advertised in area 10. Oh, sorry, not area 10, area 100. So I say interface loopback 10, IP address, let's take it as, let's take 47 so that we can easily understand. 255.255.255. So let's advertise it 0, no shut. Okay. Let me go to the process. Let's say network 47, 47, 47, 0, 0.0.0.255. Now the area is 100. Okay. So let me show you the configuration. I have 23 network advertised under area 40, and the other network I have advertised for 100. Okay, the loop back address. So let's see the neighborship relation. Okay, I don't have any neighborship, might be I have to enable them. Okay, I guess I have done some mistake in the configuration. So basically this is not 23. Okay, this network should be in this range, 10.100.100. I can take it up anything. I have 3, I have 2, I have 1. So let me take this as 4. Okay, so doing that will get this in a OSPF relation, otherwise they are in a different network. So I'll just default the configuration 0/3. I go to interface E0/3. I say IP address 10.100.100.4.255.255.255.0. No shut. So inside OSPF, I'll remove this because they are not needed. So it's network 10.100.100.0 0.0.255 area 40. Okay, now we should see the OSPF coming up. So you have the OSPF coming up. So let's see show IP OSPF neighbors. Okay, so I'm forming neighborship with this router. Now they are in a neighbors, they are in a neighbor relationship. Okay, so let me see the LSAs. So I have type 5, that's because of the default gateways, the default originate gateways. So let me see the other networks. Okay, the other ones. So this is Mumbai 13. So do we have any LSA 3 here? So just to avoid confusion, I'll close the external routes. Okay, I don't need external routes. So on Mumbai 6, I'll take them out. So the more I take out other things, so basically it will be easier for us to understand. Okay, so I'll take this out. Okay, so where's Mumbai 13? Okay, now the LSA 5s are taken down. So if you see from LSA point of view, the interface that's pointing towards 40 has LSA 1, LSA 2 and LSA 3. Okay, this is because they are pointing towards the 40 area. Now the LSA or the link that is facing towards 100, you will not see LSA 3, because if there is no LSA 3, then they are not going to get advertised. Okay, so there is no way the two networks can communicate. So let's see this on the Mumbai router 4. Do IP route. So do I have anything for 44 which is behind this router? So I have a loopback which is 47 network. Okay, so I don't have any way to see that. Okay, because that won't be advertised, because there is no LSA which will advertise the networks. Okay, so on Mumbai 13, if I see the routes, you have the route because they are directly connected, but they are not going to get advertised. See, you have even advertised in OSPF process, but that's not going to be taken to other areas. That is why we say we need to connect all the areas to area 0. That is when the LSA will get generated and then they get communicated to each other. Okay, so I'm going to configure virtual link. Now how is virtual link configured? It's between two ABRs. So this router is acting as ABR and this router is acting as ABR. So I will form a virtual link between these two. Okay, so let's get the configuration. So over on Mumbai router 13, or let's do first on Mumbai router 4. I go over here, I go to configuration T. So what is the process ID I'm using here? Okay, so it's router OSPF 1, and then I say area 40, that's nothing but the area where it's connected. And what is the virtual link? So basically, what is the virtual link of this Mumbai 13? So let's see the router ID first. Okay, so basically that should be IP address, but let's verify what is the router ID. Okay, so this is the router ID. Do show IP int brief exclude unassigned. Okay, so this will act as a router ID, or just to avoid the confusion, I'll go and manually create a manual router ID. Okay, so let's give this as router ID so that I can take this IP and place it here. So I'm mentioning my virtual link. Okay, so over on Mumbai router 4, I say the virtual link is connected to area 40, and this is the router ID of the second router. Okay, so you have to give the router ID. Now the same thing has to be done from the second router. So you say virtual links, or you say area 40 virtual link. Now what is the virtual link of Mumbai 4? So let's check that. So I do not have anything, but let me create it so that I don't get confused. Okay, so over here let's make use of some router ID. So let's say it's 44.44.44.1. Okay, it is asking me to change this process. Okay, fine, I have changed the process ID. Now I say it's 44.44.44.1. Okay, so how do we verify this? Do show IP OSPF virtual links. Okay, so when I do this, it say virtual link to router is down. Why is it down? Transit area is 40. It says it's down. Okay, so let's see why it's down. Okay, so it has come up. Okay, that's because you cleared the process on other side, so it took some time. Okay, now it says it's up. Virtual links are up. So you are sending LSAs on do not age without any timers. In case of virtual links, you're sending the LSA packets with do not age. This is also in short form called as DNA. Okay, so if someone asks you in virtual link what is DNA, that's nothing but do not age, because these LSAs are on virtual links. You do not know what is the distance between the two areas, so they can lapse the timer. So we are making use of do not age kind of timers in case of virtual links. Okay, and let's see the LSAs now. Do show IP OSPF database. So now you see there is a type 3 LSA getting generated. Okay, so the type 3 LSA for area 100 got generated. Now let's see from the second router, Mumbai router, do we have the networks learned? So what is that network? It was 44 series network which was behind the virtual links, right? So where is this 44? It's over here. So I can see now these networks are being learned on this router. Okay, that's because you have virtual links coming in. And technically what is happening? So technically when you have OSPF configuration, you will see the LSA3 are not getting generated. Now this, because of this LSA3 is when the two areas communicate. Now when there is no LSA3, there is no communication happening between two different areas. I'm not talking about backbone, any two different standard areas. So what I'm going to do is I'm going to create a virtual link with my area 0. Now what happens? I can see the LSA3 coming in. I can see my routes are getting advertised and vice versa. I can see all the other networks that is over here on the routers which is inside virtual links. Okay, which is transit area now. Now this area is called as transit area. Okay, the area which is transiting these two areas over on virtual link act as a transit area, or we call it as transit area in the OSPF terminology. So if I go to Mumbai router 23, Mumbai router 13, sorry, if I see the networks show IP routes, so I will see all the networks. Okay, and from database, what all database do I have? For area 40 I have type 1. So for area 0 you have type 1, type 2, type 3. Okay, so you will see the virtual links are advertised with DNA. That's nothing but do not age timers. For area 40, you will see type 1, type 2 and type 3, and for area 100 you will see type 1, type 2 and type 3. Okay, so you will see all the areas now. How do we check the virtual links? It's because it's with the help of this command. Okay, it says it's up, urgency is full. So let's try to ping one of the networks. So let's say I want to ping this. So they are reachable. Okay, so we have end-to-end connection. Fine. So I guess we have completed OSPF. We have done path preference already. It's your inter area, intra area, and external routes. Okay. So any doubts? Let me know before we wind up for the class today. Okay. So regarding OSPF working, we don't need area 0. Okay, we don't need area 0. Let's say I have a company where I am running OSPF area 40. So the routers within area 40 will still form the neighborship, they will behave as normal OSPF. It's only when, let's say, I have to scale the network. Let's say I'm adding up lot many routers, okay, which is beyond the area capabilities. So what I do is I'll split these two areas. So I'll bring area 40 and area 20. Now this is a problematic situation. Okay, now these two will work within themselves but not across the two areas. Okay, so that's why we need to have area 0 backbone area, and all rest of areas will be interconnected with area 0. So let's say there are some networks, they will be advertised to area 0. Let's say there are some networks, they will be advertised to area 0, and so on. So basically your area 0 should know all the routes, all the networks, and then depending upon the filtering you can just block the networks, or depending upon summarization you can uh, tune your whole topologies. So you have concepts like summarization, you have filtering, you have the default originate. Okay, so these are all used to minimize the routing. So by making use of this you can suppress the routing information of all other areas, but the best practice is your area 0 must know all the routes from all the areas. So don't ignore area 0. Okay, so that was a little bit on area 0. Okay, so might be you have not connected to audio, so that's why you don't hear anything. Do you need to configure OSPF on all routers in area 40 and 13 before configuring virtual links? No, not required. Okay, so what I did as of now is, see, this is powered off. I have not even powered on. Okay, this is not mandatory as of to show the virtual link. This was when I was trying to show you the external route like LSA 5 related concepts. Okay, as of now for virtual links it's just between the two areas. So let's say, see, this might be leading you to confusion because I do not have any other route. So let's say I have routers here, router 40 and router 50. Okay, something like this. So this act as one of the ABR and this act as another ABR. So you are creating a virtual link with the ABR that's sharing with area 0. Okay, so that's your prime decision maker here. So this ABR must be virtual connected with area 0 ABR. Okay, you don't need other routers coming up. You don't need other, so you need this because this is a switch and this is a multi-access. So rather than this switch, you do not need this, neither this. So one router here and the other router here, you can create the virtual link. You can see the behavior. If you are facing some difficulty, you can introduce 2 or 3 other routers, so then you can see the routing tables here. You can see the LSA before virtual links and after virtual links. You can see the LSA if you see the uh, LSA 3. Okay, because when I showed you the LSA 3, you just saw the LSA on this side because that was connecting with area 0. But on the other side, there were no LSA 3 because they are not directly connected with 0. That's why you created virtual link. As soon as you connected virtual link, you saw the LSA 3 coming up on this side as well. What is the next topic? We are done with OSPF, so I guess I'll start with BGP. What does this mean? I actually answered your question itself. Okay, so I said you don't need area 0 for OSPF to work. You can still have single area, and if you have multiple routers, they will still going to work. Area 0 is required when you have multiple standard areas, let's say area 40 and 50, so they are not by default going to get communicated. So in order to communicate between two standard areas, we need to have area 0. Okay, okay, so if it's an interview question, then you can say that area 0 is not a prerequisite to OSPF work. Okay, area 0 is not a prerequisite for a OSPF to work. So let's say I just turn down all these routers. Okay, I take down all the routers, I stop these routers. I'm just having one router here and other router here. Now let's see what happens. So on my Mumbai router 6, show IP route. Let me see the OSPF neighborship. So this will go down. Okay, in couple of seconds it will go down. Okay, so now you can see. Okay, give me one more second. So you will see that they are forming the neighborship without area 0, but there is no database synchronization. Okay, so to answer your question, you don't need area 0 for OSPF to work, but to intercommunicate between different areas, then you need area 0. Okay, I hope that answers your question. If not, I can give you some other example. Okay, so by default OSPF will still work without area 0. You don't need area 0. So you need area 0 in order to communicate between two different areas like 10 and 20. Okay, so by default they are not gonna communicate. So in order for them to communicate, you need area 0. But let's say you don't have area 0. Now let's say you have company XYZ. They have area 10. They will have a fully functional OSPF without area 0. Similar way, you have a company running, you have a company ABC which is running on area 20. Now you will have a fully functional OSPF. That's not an issue. But how are you going to intercommunicate? Let's say you have users here and user here, and if they want to communicate, now that's not possible. Okay, for that reason you need to bring in the area 0 so that your networks can get advertised. Okay, Yes, that's also right. Area 0 is used to avoid loop mechanism, because this is one such area which will know all other individual links, right? As I told you, you have multiple areas. You can summarize, you can filter, you can uh, define default originate. So it's your area 0 which is aware of all these individual links. Okay, so if you have some network like 47 over here, and you also have the similar network here, so that's your area 0 which is aware of these individual networks and the way they are learned. Okay, so that's your area 0 which is helping you to avoid the loops. Okay. Okay, I saw one more question which was put up. It is it mandatory for one area to be connected to area 0? Well, I would say that you are creating virtual link with the ABR that's connecting with area 0. That would be better way to define that. Okay, so when you're creating a virtual link, it doesn't make sense you create this virtual link with some other ABR. That's not going to help you. You are going to create a virtual link with that particular ABR which is acting as ABR for area 0. So this is a closest ABR. Now let's say I had this router acting as one more ABR. So I can also make a virtual link on this because that's a ABR which is shared between area 0. Now that can act as a uh, valid virtual link API. Now which area will act as a transit? Now this area will be acting as transit because my virtual links are over here, so all my networks are advertised over on this network. Okay, so these transit areas might get changed depending upon the virtual links you are building up, but yes, you need to build with that ABR which is after or getting shared with area 0. So that's a key point here. Okay, so you are just advertising it with area 0 ABR. No, I think I have defined this. So do both areas need to be directly connected? So this is not connected to area 0, right? So that is why I said if this is leading to confusion, put two routers, okay, and check the database from these routers point of view. Now they are not connected to area 0, and where am I connecting virtual link? It's not between these two. Okay, the virtual links are to be connected between the ABRs, and this area will now act as a transit area. Okay, so that's your answer. So I would suggest practice so that you get through all your confusions. Okay, OSPF is very vast subject. Okay, when compared with EIGRP, OSPF is very vast. You have to practice to understand the flows. So we have done a lot of labs and lot of scenarios, and I have covered almost every topics. So now it's all up to you to uh, power on these nodes and configure. Okay, so I have also given you the notepad configurations, so if you want to refer back, you can refer back them. So guys, that's all from my side. Next class will be with a new topic. Might be I start up with BGP or some of the IP services, it depends. Okay, so anyway, so is there any doubt? Okay, no problem, I can start with BGP. I have shared the notepad configuration. This morning I shared this. Okay. Okay, guys. So let's meet up in the next class. Have a nice day. See you soon, everyone. Thank you for joining.